Started the recording. Okay, so we're going to be talking about just financial decision making. I'm not going to go over everything in the unit. There's some simple interest problems that are at the beginning of the unit. There's some just plain compound interest problems. The compound interest problems that we're going to be talking about are not just your everyday compound interest where you put one deposit in. We're going to be talking about making multiple deposits or making multiple withdrawals or making multiple payments. So everything we will be talking about today is make depositing every month or every year, on and on and on for a number of months or a number of years, whether we're getting money or paying money in or paying off a debt. So we're going to be talking about those types of problems. Now, the other problems that are in the unit deal with either simple interest or compound interest, where there's just a one-time investment. So just keep that in mind, and it's a very important aspect of determining what you're going to do and what formula you might use, and that is determining, is it a one-time investment or is it multiple investments or multiple withdrawals or multiple payments? So we're doing those three. We're going to do three types of problems. They all have to do with the multiple deposits, multiple withdrawals, multiple payments. So let's start out question number one here. You deposit $3,000 each year. So that's not just a one-time $3,000 deposit. It's $3,000 every year into an account earning 7% interest compounded annually. And asks, how much will you have in the account after 15 years? So it's not just a $3,000 deposit and you're letting it sit there. You're going to have a $3,000 deposit. A year later, you'll put in another $3,000, which you're going to earn interest on that first $3,000, and then you're going to put in another $3,000, and it'll start earning interest. So it gets a little more complicated. Now, just for starters, the formula for deposits like this, if you were not going to use one of the apps or the programs that we're going to look at, looks like this. These investment problems are called annuity investments because you're paying month after month after month into it. It looks like this. Your balance in the account can be calculated by taking your payments and you multiply by, double parentheses there, 1 plus the interest rate, which in this case is 7% or 0.07, divided by, some books use N, some use K. That's the number of compoundings each year. And so in this case, K is equal to 1 because we're doing 1 per year. If it were monthly, we'd be doing 12 per year. And then we have K times T. T is the number of years, so that's 15 years. So our T is going to equal 15. I'm going to clean this up a little bit, make sure you realize that is K is equal to 1. And then, and this minus 1, and then you multiply by K over T. Now, a lot of the formulas have it dividing by, K over R, not K over T. So K over T. Now, some of the formulas, instead of multiplying by K over T, gosh, I did that again, didn't I? It's K over R, not K over T. K over R. Some of them divide by R over K. And so I hope you remember that in fractions, if you're dividing by a fraction, you can invert it and multiply by the same thing, or multiply by the reciprocal, K over R. So that's what the formula looks like. And so our payment is going to be $3,000. So you'd have to put that into your calculator and, be careful and make sure you get everything that it's done properly and all those little details to make sure you get the right balance. So I'm going to show you what we're going to do on the TI-84 first, and then I'll show you what we'll do on the computer. Now I have the computer app is listed it's on the it's made available on the exercises. It will be available on the quizzes. And so we'll do that one after. But if you did it by hand, you'd be plugging all those numbers in. You'd be plugging in the balance. You'd have to do that by looking at 3,000 times parenthesis 1 plus 0.07 over 1 to the 1 times 15 power minus 1 times 1 over 0.07. And it's nice when it's once a year because, I mean, what's 1 plus 0.07 over 1? You can just, that's 1.07. 1 times 15 is just 15. So these kinds of things, this part, on a problem like this, you could do that all in your head, right? Anyway, I will show you then, if you were to do that on the calculator. To plug all that in the calculator, 3,000 times parenthesis, so we get 3,000, and then you just use double parentheses, 1 plus 0.07, and I don't need to divide by 1, I know this one. And then and then 1 times 15 is just going to be 15. We go over here and hit minus 1, close parenthesis, and times 1 divided by 0.07. And that gives us this $75,387.07 approximately. So that's if you were going to plug it all in by hand into the formula. Now, rather than using that formula, the calculator has an app on it. And so let me note something here. Do you notice where it says app on your, if you have a TI-84, there's a button there that says apps. So I'm going to clear everything here and I'm going to select apps. And I'm going to click 1 for finance. And then the TVM solver is what we're doing. So we click 1 again. And this is what we get. This is, all we do is plug the numbers into this. And you have to understand what each of these stands for. Now, N, I'm going to go ahead and write on here, and you may want to write this down. It's not 30 in this case. N is equal to, that's the number of times you're going to compound. It's 1 times 15. It's the K times T. It's the number of deposits. Okay. The percent, I is the percentage, and you don't convert it in this one. It's the percentage interest rate. And we'll come back to that. PV stands for present value. So when you're making an investment, when you're starting out, you don't have anything. So you want to write present value there. That's what that stands for. What do you think PMT stands for? Anybody got a guess?
The payment amount.
That is the payment. Now the payment could mean a couple of things. In this case, we're making payments. We're putting money out. It was $3,000 every year. And so that payment in this case was $3,000 per year, and K was once a year. So sometimes that payment will be money if you've made an investment and you are getting money back from that investment in an annuity, like a monthly income from it, then you're getting a payment, okay? Then you're receiving a payment. If you're making a loan, then you're giving a payment. So we call them payments, whether you're getting the money or giving the money away, if it's done on a regular basis. So payments could be payments coming to you or payments going from you, to or from. What do you suppose FV stands for if PV stands for present value FV, of course, is going to stand for
Future value.
exactly future value. And P/Y is payments, what, per
Year.
year, of course. And C/Y, these will always be equal, by the way. They're always the same. That will be the compoundings per year, which is K. K is the number of compoundings per year. It's the same K as up here. This K is the same as that K. Okay? And this end means we'll make the payment at the end of the month. And all the problems we use end on. Although it's not always practical. Sometimes you really, in real life, you use beginning at the begin. You get things at the beginning of the month. But in all the problems we do, we'll use end. Okay, so now what do we plug in here? We know that n, in the case that we were just looking at, in our case, our n is 1 times 15. So I can put 1 times 15. Of course, you don't need to put that in. You know 1 times 15 is 15. The interest rate, if I move this down, wasn't the interest rate 7%? So I'll put a 7 there. Now, in the formula, we use 0.07, right? Because R you write in decimal form. But in this program, you just put in the 7. Now, we'll hit enter. We can either hit enter or we can hit down arrow, and it'll take us to the next one. Now, what is the present value? I mean, it says we're going to invest $3,000. So when you're starting an investment, how much is in the account already? You're starting out with 0. So every time you make an investment, you're doing an investment, you start out with 0. If you're borrowing money, then the loan amount is a large amount typically, and that's the present value, is the loan value. Or if you've already saved money and you're going to retire and then you're going to take money out of your account, then you put the account value, the balance, original balance in there. Now, what are the payments going to be? I'm going to hit enter here, and you see I hit down arrow once, I hit enter, it's the same thing. What are our payments going to be? What were those? 3,000 per year. So now, since that's money going out, I'm going to say negative 3,000. Typically, our payments are negatives. Payments are typically just negative each time. Now, what's the future value? I hope it's not 0. Does anybody know the future value? After 15 years, that is what we're trying to find out, isn't it? So that was, nobody answering was the correct answer. We do not know yet. Okay. And notice that I'm going to get down there. Notice I put a 0 in there though. And if there was nothing, if I cleared that and I tried to go down, watch, I'm going to hit the down arrow. It will not let me do that. It will not let me hit enter either. If you have a blank, it doesn't let you go. So you have to put something in there, even a 0. Then if you hit down arrow, it let you go. Even if I hit 555, you don't need to have any, you can have any number in there. It doesn't matter. We're going to fix that. Now, P/Y is payments per year. And remember, it said 3,000 each year. That's 1 time a year then. We're putting that money in once a year, and it's compounded once a year. These will always agree. In fact, watch. If I push in 5 here and then I hit enter, it automatically changes that to a 5. If I put a 7 here and hit enter, it will, oh, it's supposed to change that back to a 7, but it didn't. But this is supposed to be a 1. It's once a year, and hit enter, and there we go. So now I'm going to go back. Here's how you calculate it. You go back onto what you're looking for. This is the unknown, right? This is what we're looking for. This is the value in here that we don't know. So you have to basically, you have to know everything in here except one thing. This one thing is we can have in question. So I can leave it as 555 or put a 0 in there. It doesn't matter. If I hit, now you hit alpha, see the green button that says alpha? Click alpha. And then down here, you can see if you look in your calculator, it says SOLVE, solve on the enter. So alpha, enter, and voila, it gives you the value. That means if for 15 payments at 7%, starting out with nothing and putting away 3,000 once a month, once a year, 3,000 per year, you get $75,387.07. So that's what our result would be. Okay, I'm going to go ahead and clear all that, all those drawings. Did everybody get any this? If you want to take a picture, go ahead and take a picture of that. I'm going to clear that in a second. Okay. So this is our answer then. That's what we're going to use, 75,387.07. So that would be the answer here, 75,387.07. Now, the questions we should be asking without even just a natural curiosity, just with a natural curiosity, would be, wow, well, how much money did we really put in? You know, if this is 75,000, if we made 75, if we have $75,387 in the bank now, or in the account now, we only put in 3,000 per year. And that was only one time per year for 15 years. Well, 3 times 15 is 45. So that was a total of $45,000 that we deposited. And we got 75,000, over 75,000. That is $30,000 worth of interest. Okay, $30,000 worth of interest. Now, what if we spent, instead of 15 years, let's take, this is what's really nice about these programs is you can so quickly change things. What if we put it in there instead of 15 years, making 75,000, what if we put it in for 30 years? Okay. So I'm going to punch in 30. And before you try and get the answer, that's twice as long. So instead of $45,000, we'll be putting in 90,000, right? Because twice as much, twice as long, twice as much money. Now that was 75,000. What do you think is going to happen to the future value? Since we put it in for twice as long, that's twice as much money. Do you think this is going to double?
Yeah.
Okay. Well, let me tell you something about compound interest before I push that answer. Compound interest is an exponential growth, and we just talked about exponential growth. And remember, exponential growth goes like this. And what happens? It gets steeper and steeper and steeper. See that? The further out you go, if you're here and you go out twice as far, you're going to be a lot more than twice as high. You'll be way up here. Okay? So watch what happens when we go down to that future value now, and we hit and we click on alpha solve. $283,382, $283,382.36. So that is, before we put in, remember we put in $45,000. I'm just going to write this, 45K, 45,000, and it grew to 75,000, about a little bit more. Now we put in 90,000. And by the way, this was 15 years. Now we put in 90,000, and in 30 years, it grew to 283K. So here we made 30,000 in interest. Here from 90 to 283 is almost $200,000 in interest. And that is the magic, the miracle of, some people say, a wonder of time leverage. The longer you invest, the more money you're going to make. Now, the average student at YVC, their age is a little over 20 years old, and many of you are near 20. Some are a little older, and some are a little younger. But if you started investing when you were 25 and you invest until you retire at 65, that's 40 years. Imagine what you can do in 40 years. So it just this is just to wet your whistle, get you interested. Let's say that instead of 30, let's say you go for 40 years. And let's say for instead of 3,000 a year, let's talk about money that is, here's what we've found among college students is, now this is pre-COVID, college students were averaging almost $17 a week on drinks of some kind, whether they were, coffee or tea or soda or water even. You know, uh, we do not ever buy bottled water. Never buy it. We have a Brita filter, and it filters perfectly good. You buy a filter, it's very cheap. It's so much cheaper than bottled water, and it doesn't waste plastic. We don't have plastic recycling and waste. Even recycling takes a lot of energy. So a Brita filter is so simple and it's cheap. And by the way, bottled water doesn't have the same rigid standards that your tap water has to have. So filtering tap water is actually better than almost better than almost any possible way you can get water. Filtering tap water is great. It's better than that bottled water. So we figure students save, they on average it's $17 a week. So even now, I know in COVID we're not going out as much, but in general, if you spent $15 a week on average but if you went and just drank water, which is healthier than a lot of the drinks we drink, then 15 times 4, that's $60 a month. So let's go 60, oops. If we do it per month, then it'll be 40 or 12 times 40, right? This will be monthly. So we're not going to put in very much, 12 times 40. And let's even go to 6%. And by the way, 6%, if you go to an investment company and you're a college student, they would love to help you start investing anytime. You can go to Edward Jones or Waddell and Reed or Prudential or Merrill Lynch or any kind of investment company, and they're going to help you invest because they love to help college students start to save, because they know if you start now, you'll do more later after you get a better job, right? Supposedly. So anyway, and this would be 12 times a year. This is normal. Most people invest monthly. Now look what would happen if just $60 a month right now, which is people's kind of, a lot of people, it's called, we typically call that, money that you can maybe probably do. Yeah, we call, it has a, oh, I forgot the name. Okay, we have a name for it. I just, anyway, what's the future value? $60 a month, not very much. Oops, I put in the negative in the wrong place. That's supposed to be a negative 60, right? Negative 60, because it's going out. This is how much you'll have to come back. $120,000 almost. So that's, now what is that? How much are you really putting away? Well, if you're doing $60 a month, that's 12 times 40, right? So you put away a pretty good amount of money. So what is 60 times 12 times 40? If you do that, do the math there, 60 times 12 times 40. I can actually quit and go out. I'll do it right here. Second quit. That's how you get out of this, by the way. Second quit. There's a little quit up there. You go 60 times 12 times 40. You're putting out less than $29,000. And if we go back to that app, $29,000 is all you put away. And look at what you get. $120,000. That is $90,000 of interest in 40 years. And you start adding that up. If you start putting away more than 60 a month, when you get if you get a job where an employer puts away money for you, I mean, that can go into 600 a month easily. So, you know, you're talking a lot of money. And you won't do that for 40 years because you'll be older. It might be 4 or 5 years before you start investing. So it might be only 30 or 35 years you invest for. But I'm just trying to persuade you that in your life, this is real life stuff. And this is, I just want to, I want you to think about investing. Because so many, that's a problem with America, is a lot of people didn't put any money away and they have nothing for a rainy day. They don't have anything for retirement. A lot of people in their 60s just have, they're going to depend on Social Security, and it's not always good enough for good health. And I mean, we do have Medicare at that age, but anyway, you know, it doesn't leave you a lot of room. So anyway, now, for those of you who do not have that TI 84, I'm going to go to, let's go to the, okay, there was. Let's go to, here's the exercises. In the exercises, you'll see it says right at the top, when you open this up, it says resources. There's an online calculator. Now, I think if you click here, it'll open the calculator right here on the page. If you click here, it'll open a new tab for you. So you can click right here, it'll open it right here, and you can work the problem right on the page. And now I do have to make it bigger. I gotta kind of move it around. And now this calculator does all different kinds of things. This is an amortized loan. This is paying back a loan. So I'm going to show you that this will do. You have to scroll down on this, and this is if you defer a payment on them. There's a bond, paying it back a bond. We don't do this. We're not doing a mortgage. We're not doing a lease, auto loan related. We are doing an investment. There's the investment calculator right there. So I'm going to click that. And here it gives us an investment. Now, this is kind of interesting. Okay, so the starting amount, if you remember, we had nothing to start with. Oh, wait a minute, wait. Yeah, we are starting with 0. And I think this was 15 years, right? So you put in the 15 years. And the rate of return we had was 7%. The additional contribution, if you remember, was 3,000. And were we contributing at the end of each month or the end of each year? It was the end of each year. And so now we hit calculate, and it tells us right here, the ending balance is $75,387.07. That's the same thing. But additionally, this app also shows you that for $3,000 at 15 years, it tells you how much you put in, 45,000. It tells you what your interest was also. Okay. All right. Look at this. It tells you, here's your green is your balance. This shows you what your contributions are. And then this tells you what your interest is. So look at your interest is catching up because you're getting a higher balance. That gives you more and more interest. Anyway, that's kind of a cool graph. All right, so I'm going to go ahead and shut that. So I'll remind you how to do that again. So let's look at the second question. This says, suppose you have 400,000. You want to have $400,000 for retirement in 25 years, and your account earns 4% interest. How much would you need to deposit in the account each month? So let's go to the calculator, the TI-84. Remember, you want $400,000. This is at the end. This is what is going to be our future value then. You want to have 400,000 for retirement in 25 years. So this is a future value. Our time, the number of years is 25 years. Our interest rate, that is I, is equal to 4%. Now, you know, if you use the formula from the book, they use 0.04 for R. It says, how much do you need to deposit in the account each month? That means you're going to do payments per year, and compoundings per year is going to be 12. So that's K. K is equal to 12. So remember that N is equal to 12 times 25. And then it gives you interest is going to equal 4, because that assumes a percent. Then it asks for the present value, then the payment, then the future value, and then I'll just write PYCY. Those are both going to be 12. Now, the present value is 0 because we are starting out with an empty account, and we don't know what the payment is. And we want our future value to be 400,000. So I want you to take a look at that. This is what I would expect to see for your work, for that problem. That's all the work you'd really need to show me, okay? You could also just take a picture of I guess you could take a picture of your calculator and show me that too, but then you've got to upload the picture. You could just type this in really easily if you wanted to, but that's how I would do that. That's how you should show your work if you're going to use the TI-84. And actually, even if you use another one of even the online calculator. So I'm going to bring up that TI-84 and plug those values in. Sorry, it's taking so long. Okay, this over here. So I'm going to put in 12 times, what do you say, 25. It's 25 years. They said 4%. Our present value is 0. Our payments we don't know, so I can just leave that as -60 if I want, or 0. The future value, didn't they say they wanted 400,000, right? And then it's already on payments per year and 12 and 12. So now we'll go up to payments and we'll hit alpha, solve. And there it is. You're going to need to put away $778, and really, I would say that you put away 2 cents, or else you'll be a little short, because you're going to be almost a half a penny short every month. So you put 778.02 would probably be the best way to round that, even though that's not, in money, we don't always round to the nearest. Often we round it up to the next, depending on what it is. Not when the bank owes you money, but when you owe them money, they always round it up. So anyway, let's, so 778.02. So let's go ahead and clear all these, and I'll minimize this. And how much did you do? There it is, 77. Oh, they, in the WAM app, they did 778.01. By the way, if you come up with something, if you get an answer and it's off by a penny and they mark it wrong, just definitely go down here and message the instructor and tell me, because I'll go in and I'll change that, and I'll make sure that you get full credit. Anytime you have a problem like that and you think you did it right, let me know. Just message me and I can check it. Now, let's go back up, and I closed this. I closed this resource. Oh no, I guess I didn't. It's somewhere on here. It must be down. Where is that? Dell touchpad, no. I think I need to go like this. No. It's not letting me open it in the thing, which means it must be already opened. But I don't know where it went. Oh, here it is. Come on, come on. Nope. Well, I'll go over here. I know we have it here too. This is if you open it in a tab. I already have it in a tab. So now I've got to go down again Oh, by the way, this is what it shows you about a loan. See, similar kind of thing. So we slide down here to investments and wow. Oh, did I go past the, that's the loan calculator. Uh, Now this is not what I wanted. Let me go back to this. Okay, if we do this, if we hit online calculator, it'll bring us, there's the loan. Oh, here's other financial calculators, loan, interest, retirement. Yeah, investment. We'll just click investment. Yeah, click investment. And then our starting amount again was 0, wasn't it? Because this is investing. And we were going to go for, wasn't this 25 years, right? And the rate of return was 4%. And we were going to, this was unknown. We did not know what our amount was going to be. Oh, this one isn't going to give us, oh, this calculator isn't going to give us our final amount. Yeah, we don't have that on this one. This calculator is not going to work for that. Calculator, financial. Okay, it doesn't give us a blank for that one. Okay. I've got to give you a different calculator for that. An interest calculator? That's not it. Nope, that's not it either. That's not giving you that option. Okay, I'll get you a different calculator for that type of problem. So this one, we need the TI-84 to do that. Now, how much interest will you earn? Let's finish this with our TI-84. Suppose you want to have $400,000 for retirement in 25 years. So if we take 778.01 or 02, I'm going to change it to. If we take that and we invest that, if we take 778, I'm just going to do 015. That's what it was really. Nah, I'm going to do 02. I would not. I don't know why they rounded to 01. It should bump it up. But anyway, we're going to do that 12 times a year, right? 12 times per year times 25 years. So that's going to be, let's do that on our calculators. Well, I guess I'll do that here. Yeah, 778.02. So now I have to go second quit. 778.02 times 12 and times 25. Let's double check. That was 25 years, right? 25 years. And that means all the money we put in, that's a lot of money, $233,406. Okay, 233,406, right? Oops. That means we invested out of pocket. You deposited that amount. Again, I forgot it, 233,406. 233,406, right? That's how much money you deposited. But look at how much money you get out. You get out $400,000, or you get $400,000 at the end. This is all you put in, and this is what you get at the end. So what do? You subtract your total value, your total balance. You have to subtract what you put in, and that's going to tell you how much interest you made. You see? That gives you the amount of interest that you made. So that's going to be what, 594 to add up to there. And 399 minus that is going to be 166. You're going to have made $166,594 in interest. Okay, this will be a little bit different, yeah, because I used 02 and they used 01, so they have a little bit more interest than I had. I had 04, 94. Anyway, there's a leeway in the program that allows you a little bit of variation. A couple bucks off there is no big deal. Yeah, this is really not the right answer. This is closer to it. But anyway, does that make sense to everybody? Are there any questions about that?
I have a
Now,
question.
yeah,
How would you express it though, like in a math equation without
okay,
using that
that's
calculator?
a great question. So the balance, if you're making an investment, the formula is the balance in an account is equal to the payment times 1 plus the rate, the interest rate as a decimal over the number of compoundings times KT minus 1, and then we multiply by K over R. And so in this case, our payments are 778.01, right? Oh, wait, sorry. If you didn't know the payment, right? We're finding the payment. So the balance we want to be 400,000 and our payment is unknown, right? This is what we're looking for. So you're going to plug in 1 plus, you're making 4%. So this we put in R in this case. And you're doing it 12 times a year. Remember, it's each month. So that means K equals 12. And it's 12 times 25. Remember, it's 25 years. So T equals 25. That's T is the number of years. Minus 1. And then we get 12 over 0.04. So I'll show you, if I'll put that into my calculator and show you what that part gives us. This is just step 1. So you have to put in that, that's too big. You have to put in the parenthesis, 1 plus 0.04 divided by 12, okay, to the power of, now notice it's 2 parentheses there, to the power of, it was 12 times 25, right? It's 25 years. And then we have to hit a right arrow to go down. Now, if you don't have a calculator that puts the exponent up there, you have to put parentheses around the exponent, or else it'll just raise it to the 12th and then take the answer times 25. So you have to have parentheses around it unless it shows it like this. And then it has a closed, then it has minus 1 and then a closed parenthesis and then times. Now, the book shows you a formula that says divide by 0.4 over 12, but I always multiply by the reciprocal, 12 over 0.04. And now that gives me 514.12. I'm going to write that down here. Oops. Make that smaller. Come on. Move this out of the way a little bit. So there's that number. I can't win for losing there. 514,129. This is 400,000 equals the payment, which we haven't figured out yet. This number turned out to be 514 point whatever, right? 514.1295. 1295. 1295 ... And what do we do to solve that then, Lionel?
You would divide it on both sides.
Then you divide that number. So you got to make sure you finish the problem by dividing by 514.1295 on both sides. And that's not very hard to do if you have that in your calculator already, because you can just take 400,000. I'll do it here. 400,000 divided by, and then I go second answer because that number is right there in the calculator already. It was the last answer. So I hit divide, and there's my 778.014, right? So that's how you do it with just using the formula in your calculator. It's not too bad. I mean, you can do that. Okay. What do you think, Lionel? You want to take a picture of that?
No, I wrote it down in my
Okay.
notebook already.
All right. Okay. So let's go ahead and scroll down to the third problem. This is now we're going to do borrowing money to buy a house. So this is, we're going to use the same thing. The TI-84 uses the same formula, the same app. It says now you want to buy a $237,000 home and you plan to pay 10% as a down payment and take out a 30-year loan for the rest. So we can see here that in this case, the interest percent is 10. And if we use the book formula, we use R is equal to 0.1. Oh, no, that's not. That's not the interest rate. That's the down payment, right? That's 10% as a down payment. Out here, it tells you the interest rate is 5% on the loan. So this is a good question. If you're going to make, now this is important, a down payment means you're going to pay, you can't afford, not many people can say, I'm going to just give $237,000 for your house unless they've sold another house that was worth a lot more and they can pay cash for it. Most people just pay a little bit of this so they don't have to borrow the whole amount. And most banks and loan companies make you pay part of that value. So if you pay 10% of that, then you don't borrow, you're not borrowing the 237,000. You're only borrowing what's left after you make partial payment of that. So you have to make a down payment. So there's two ways to do this. The quick way is to say, hey, how much is my loan amount going to be worth? Instead of all of this, it's only going to be 90% of $237,000 because we're paying off 10. So we can just take 0.9 times 237, or 237,000. Pretty quickly, 0.9 times 237,000. And there we are. That's 200. Now I got my calculator, $213,300. So that's all you have to borrow for the loan if you're paying 10% down, which means, by the way, 10% of 237, what your down payment amount, your down payment is 10% of 237. And when you do 10% of something, you just move the decimal to the left one place. So that's 237.00, which is $23,700. So that means you're going to have to save that money somehow. So you might make investments in order to save $23,700 or however much you can save to go towards the house. So that gives us our loan amount. Now, to find your monthly payments with an interest rate of 5%, this is going to be using the exact same app on the TI-84 as we were using with the investment. So we'll go to that TI-84 and I'll remind you, let's go through this again. This tells me that the interest is 5%, right? And what did it tell you? It's and their monthly payments. So that tells me K is equal to 12, right? So we use that. K is important. That shows up in multiple places on these problems. So that K, if we go to the app, now let's go through this again. Remember, apps is right here. You click apps. Then you can, the truth is it says it's already on finance. So you can just hit the 1, you can click enter and enter. You don't have to push the 1, you can hit 1 or enter. And then, oops, I don't want that in the middle of there, but so anyway, now N is, if you remember N, recall, N is K times T, that's N. So in this case, it's going to be 12 times 30 because it's a 30-year mortgage. Pretty common, 12 times 30. And the interest rate it said was 5%. Now the present value is the what? What's the present value on this? Anybody? Remember this?
Is that the 237,000?
It's all not quite.
Or, oh, sorry, the 213,300.
That's the 213 now. Now, see, now you're making a payment. You're trying to get rid of this. We owe 213,000 and we want the future value to be what? 0, right? So now we go up to the payment and we hit alpha solve, and it tells us that that's going to cost us $1,145. And really, here's what the loan company is going to tell you. They're going to want really 5 cents, 1145.05. Loan companies round it up, or else this fraction of a penny will work against you. But anyway, that's what the value is, 1145.04. That's so small, they might just leave it at 04, but anything bigger than like 2 or 3, they always round it up. But anyway, there's 1145.04. That's the monthly payment. Does everybody, are you all able to do that on your calculator? Okay. And now it asks, what will your monthly payments be if the interest rate 6%? That's super easy. If we go back here, all we have to do is go click, click, put a 6 in there, and go down to the payment and say, here's the new payment, alpha solve. And that's going to be $1,278.84. So that's a little bit more money, right? It costs you more per month if you have a higher interest rate. And that's not just a little, $1,278 as opposed to, what was it, $1,145? Yeah, that's well over $130 a month just for 1%. And so you can see it saves a lot of money to get a lower interest rate. Right now, interest rates are super low. They're like 3% now. So anyway, now you think about that for a second. You only owe $213,300, and you're going to be paying $1,145 a month if you get a 5% interest rate. What, anybody have any, does that prompt you to think of anything right there? Does it make you curious about something?
Not really.
Okay. Well, remember on the previous problems up here, we looked at that and we said, how much interest will you earn? That's an interesting point, isn't it? We paid $778 a month. We only put out so much money, and look at how much we got, $400,000, and we didn't put in near $400,000. Remember back up here with that first question, we talked about, we made double. We got interest if you made it for 40 years. Remember, we did it for 40 years. We made tons of interest. Interest is should interest you. That's my point. The interest should interest you. Now that interest rate of 5% isn't a good guide, because what happens is you're paying 5% on something over and over. On that 237, you're paying 5% at first, but then the 230 or the 213 gets smaller and smaller and smaller, right? So how do you figure out interest? Well, if you get 5% interest, if that's your interest rate, you're going to make those payments. See that payment? You're going to do that 12 times a year, right? For 30 years. Look at that. You're going to be paying a lot of money. Calculate that on your calculator. 1145, I don't care about the 4 cents. And then times 12 times 30. What are you getting?
$412,200.
Yeah, you're getting over $400,000, right? $412,214 or whatever, right? So that means this over the, this is all your payments, all payments totaled. Well, it was really nice when we were doing the investing, and all that time we were making all that interest. Well, now you borrowed money from somebody else and they're going to be making all the interest. You owed them $213,000 and you're going to end up paying $412,214.40 if you want to be persnickety. But look at that. That's almost $200,000, approximately $200,000 difference, right? That's interest that you're going to pay. Now, if you try and calculate 5% of 237,000, it's not a lot, but you'd be doing, you'd be paying that down over time. So it would be less and less and less. So it wouldn't be for 30 years because you don't owe 237 for 30 years. The payment, the value of that loan is going to be going down. Okay, but that's the kind of question I think you would be good to ask is, what about all my interest? And that gets asked quite a bit. Okay, so next problem does that. Okay, okay, so this one is a very interesting problem. So this one's going to take a little bit of time. And it says, consider that you have been making regular monthly payments already, right? Already making payments of $322.10. And it's just a 6-year loan of $20,000, maybe like a loan on a car or something, right? And the APR is 5%. It says, find the remaining balance on the loan if you have been paying $322.10 per month for 2 years. Well, remaining balance is something we haven't talked about yet, but we do know the formula. I'll remind you of the formula. Oh, actually, I didn't tell you the loan formula. It's a little different than the investment formula. This is for a loan balance. You take the payment, and on this one, you'd go 1 minus, and that would be 1 plus. I know you were asking earlier about the formula. This is R over K, and this is a negative KT times K over R. And so on this loan formula, the T is on the time remaining. So T here isn't how many years you're investing, it's the time you have left to pay on the loan. K is still the same thing, it's the compoundings, it's the payments per year and the compounding per year. And we're going to use our calculator. So we're going to use I is equal to, was that 5%? Yeah, that's 5%. And so when we do this on the calculator, we have to know what T is. Now it's important. It's a 6-year loan and you've been paying it for 2 years already. So what does T equal? How much time do you have remaining?
4.
Yeah, you have to take 6 years and you've been paying for 2 years. So you have 4 years left, right? That's remaining. If you want the balance on the remaining amount, you plug that in. And so on our calculator, we're going to go through and remember it's a $20,000 loan. Our payments are $322.10. Now we don't need this 20,000 is no more because now we have a new loan balance. This is the old loan balance. So this loan balance, the loan balance changes over time. So now we don't know what the loan balance is. So I'm going to go back up to the top. These are monthly payments, so it's 12 times, and we said there's 4 years remaining. The interest rate was 5%. The present value is unknown. I'm going to put 0, 0, 0, a bunch of zeros there. Okay, that's unknown. The payments we said were 322.10, right? And the future value we do hope to be 0, right? That's what it's going to be paid off at some point. But remember, we only have 4 years left, so this present value is no longer 20,000, right? After 2 years, you don't owe 20,000 anymore. So the new present value is alpha solve. Oops, why is that a negative? Because I didn't make my payment a negative, which I was supposed to do. So I got to put a negative in there. Go back up here, hit alpha solve. 13, it gives you the same number, but with a positive. 13,986.53. That's the current value on the loan. Okay, you click on that, 13,986.53. Did everybody get that okay? So now's where it gets interesting. How much of the loan have you paid off? What two things are you going to subtract? I'll give you a hint. The original value was you originally owed 20,000. You no longer owe 20,000. You only owe this much now. This is what you now owe, right? So it went from 20,000 down to a little under 14,000. So it looks like you paid off about
$1,000 roughly.
about $6,000. So we would take the original, the 20,000, and subtract the 13,986.53. That's all you do. So the way to, it's important that you know how to find the remaining balance on a loan. And so we'll go ahead and click and double check that. What does that come out to be? A little over, look, 13,986. That's $6,013. That's what you've paid off. And now the question you should be asking is, well, I've been paying $322 a month, and I've only paid off $6,000. So in the first 2 years, it says, what is the sum of all those monthly payments? Well, the monthly payments were $322.10 per month for 12 months per year times just 2 years, right? This is how long, this is what we've paid so far. This is we've paid already. Now, so some of what we paid went to principal and some went to interest, right? The first thing they do out of this $322 is they take money out for their interest, and then they apply the remaining amount to the principal. So all of that money, if we do that under calculators, so everybody do that, 322.10 times 12 times 2, it's 24 payments. That turns out to be $77.30. Okay, that's 7730.4. That means that the difference there, you paid 7730, and this is all that went to principal, which most of it did then, really. They didn't make a ton of interest. That's really their payment. They didn't make a lot of interest because it's only a $20,000 loan, and 5% is not a real high interest rate, and it's only been 2 years. So it says, how much of all the first 2 years of payments would have gone to interest? Well, that is when you're going to subtract the 7730 minus the 613.47. Go ahead and clear this other stuff. So this is what you paid already. You paid 7730.4 or 40, and only $6,013.47 went to the balance, or what we really call the principal, that must mean the remaining, the difference is the interest they get. Okay, so 7730.40 minus 60, 13.47. That's what you do for that. And that is going to be, oops, that's going to be this 1700. See, 1716.93. If you do that subtraction, you get a 3 there. Let's see, you get 3, you borrow, that's 3 minus 4 is 13 minus 4 is 9. 0, you got to borrow there. 9 minus 3 is 6. 2 minus 1 is 1, and 7 and 1. 1716.93. Exactly. Okay. That's the idea. That's the, some people will talk about refinancing later. And that's the writing assignment, is about refinancing, and it's kind of looking at all these kinds of things as how much do we still owe on a loan? And anyway, the writing assignment is kind of what culminates this chapter, this unit. All this other stuff, it's pretty easy arithmetic. And if you use your TI-84, it's just plugging in the right numbers. Okay. Does anybody have any questions at this point? Am I going too fast? Made pretty good sense. So there's one more idea. I got 2 more problems, but I'll just do one more. I'll just do one of these. Let's say you've already saved money. You're going to save money, and you want to start withdrawing money out of your account. So there's 2 types of problems on this. One is you already know how much you saved, and so you're done. You've saved $500,000, and then they ask how much can you then take out each month or each year in order to, when you're making interest on it, you can take some of that money out and keep doing it for a long period of time. And that's the question, how much you'd be able to pull out. So that's asking for payments. This is just like a loan repayment. You put the $500,000 in for the present value, and you find out, and then your future value is going to be 0. And you put your interest in and your 20 years, and this is each month, so monthly withdrawals. So you get 12. So I'll show you. This is a little different. This one says they want the payments. You want to be able to withdraw 50,000. So let's say right now you want to be able to withdraw 50,000 out when you're in the future, when you retire. This is what you have to do to calculate how much would you need to save. How much do you think you'd need to save if you wanted to get 50,000 a year for 20 years? Say you retire when you're 65. I'm going to spend my money till I'm 85, and then I'm going to live on my children, live off my children or whatever. So you say, okay, how much will I need in my account if I want 50,000 a year? So to do that, we go to this calculator again, and it's 20 years. Now, you should do a couple little things here first. One is 50,000 is what you're withdrawing. That's each year. So that's like a payment. Each year means your K is equal to 1. You're just doing it once a year. This isn't a monthly withdrawal. This is one time a year. And then T is equal to 20 years. Your interest is going to be 7, right? We know your interest percent is 7. And is 20. Yeah, that's all we need, because what is N? N is K times T, 1 times 20, right? Remember, I'll go up here. This is 1 times 20. You're going to make 20 withdrawals. Our interest rate is 7%. That's pretty good interest rate. Your present value is what's unknown. You know, we don't know, whatever. I'm just going to put any number in there. But we know our payments. We want to be taking out 50,000 every year. And we're going to run that down to 0. And then, but here's going to be annually. So that's going to be a 1 there, and you hit enter and it gives you a 1 there. And now I'm going to go back up to the present value. How much do I need in the account to start? What has to be in that account to begin with to withdraw that money? And I hit alpha, solve, and it tells me right there, $529,700. So that's almost $500,000. Okay, 7% is a pretty good interest rate. So there you are. You need about $529,700. Let's just double check that. Make sure I didn't make any silly mistakes. There you go. And then this is an interesting question. Remember, we always want to find out something about interest. It's always of interest. The interest is of interest. How do you calculate how much interest you're going to get? Well, you're going to be pulling out what? 50,000 a year for 20 years. So to find the interest, you have to find their interest is going to be, you get 50,000 per year for 20 years. Well, we know 2 times 5 is 10. And then there's 1, 2, 3, 4, 5 more zeros. That is how much money? $1 million. If you take 50,000 a year for 20 years, that's $1 million. And look at all you had in the account was $529,700. Well, the interest, that means how can you take out $1 million when all you had was $529,700? Is you were making interest every year. Even though you're taking some of the money out, most of it was staying in there. So it kept making interest year after year, and a little less as time went by. So if you subtract those two, $1 million minus 529 is like $470,000, right? Oh, how much total money will you pull out is $1 million. And how much of the money is interest? That's when you subtract these two, 1 million minus the 529. Okay? So anyway, that's pretty much a nutshell of the 3 types of things you're going to be need to calculate with. One is you're going to have to do the multiple deposit types things. You're going to have to, will have single deposits, and I didn't cover that today. So you have multiple deposits. For multiple deposits, you have investing money, and you know how much it takes to get a certain amount, or how much a certain amount will be if you know how much your deposits are. How much a loan is, if you know what your payments are, or how to find the payments if you know what the loan is. And if you have an annuity, these are called annuities, by the way. When you take money out, when you build up an annuity account, then you'll take money out. And one is how much will you need in order to retire with a certain amount of income, or how much income can you get when you know you have a certain amount retired already in there. So pretty much always you're either given the payment or you're finding the payment each time. They either tell you what the payment is, or you are finding what the payment is. And the other one is if they give you the payment, you're going to be finding out what the loan amount was, or what the annuity value was at the beginning, or what it's going to be at the end. So it's always going to be the payment, future value, or present value. Okay, so and I'll remind you again that each problem in the assignment has a video for it, and it shows you each problem has a video with the TI-84 on it. Okay, how to use the TI-84. So it also shows you how to do it by hand. without the TI-84, you can do it with the formula. And I'll be making another video where it shows how to do it with that online program. I thought had something else on it, and it didn't. So I got to change that program. But anyway, I'll update that and keep you abreast of that. Is there anybody have any questions?
Yeah, I have a question. On the assignments, it's called financial quiz work upload, and it's just past due date of Saturday the 10th, 24, 20. And so I was wondering where you're gonna fix that.
So tell me that again. What's the problem?
It's not problem. It's for the because I look
What's the
in
issue?
financial quiz work upload, and then I check underneath, and this is the past due of Saturday the 10th, 24, 20. So I was wondering when you're gonna